There's a moment in every scientist's career when the data stops making sense, when you run the calculations once, then twice, then a third time, hoping you made a mistake somewhere. Because if the numbers are right, everything you thought you knew just became wrong. For the team studying 3I Atlas, that moment came when they measured its mass. They expected a small, fragile comet, the kind that breaks apart under the sun's heat. What they found instead was a 33 billion ton giant, racing through our solar system at impossible speeds. But the real mystery isn't what they found. It's how something that massive could have stayed hidden until now. 3I Atlas isn't just any space rock. It's only the third confirmed interstellar object humanity has ever laid eyes on. The first was Oumuamua, the strange, cigar-shaped visitor that sparked debates across the scientific community back in 2017. The second was Comet Borisov in 2019, which appeared and behaved like a normal comet, albeit from another star system. When 3I Atlas showed up, astronomers thought they finally had a straightforward case. It was releasing gas and dust as it got closer to the sun, behaving exactly like comets do. Everything pointed to a typical interstellar comet. Nothing particularly unusual about it. At least, that's what everyone thought. Until the numbers started fighting back. The data wasn't just off. It was impossible. Then researchers at Harvard decided to take a closer look at the actual numbers. What they discovered changed everything. This object isn't just heavy for a comet, it's monumentally massive, weighing over 33 billion tons with a solid core about 5 kilometers wide. We're talking about something 3 to 5 orders of magnitude more massive than Oumuamua or Borisov. And here's where it gets really strange. An object this massive shouldn't be our third detection. Statistically, we should have spotted dozens of smaller interstellar objects before ever finding one this big. Yet somehow, this enormous body slipped through unnoticed. So the question became, did we get lucky? Or are our eyes still closed? The breakthrough came from a team that included Richard Cloete, Avi Loeb, and Peter Veresh from Harvard. From May to September, they compiled data from 227 observatories across the planet, all tracking 3I Atlas as it moved through our solar system. The method was simple. Measure where the comet is, compare it to where gravity alone would put it, and see if there's any difference. That difference is crucial because comets don't just follow gravitational paths. When they heat up near the sun, frozen gases turn directly into vapor, shooting out jets of material. These jets act like tiny rocket thrusters, giving the comet a slight push. Astronomers call this non-gravitational acceleration. The amount of push depends on how much gas is escaping and how massive the comet is. A lightweight comet gets shoved around easily by its own jets. A heavier one barely budges. When the Harvard team looked at 3I Atlas, they saw plenty of outgassing. The comet was clearly active, but the non-gravitational acceleration was surprisingly weak, measuring less than 50 meters per day squared. The jets were firing, but the comet wasn't moving much in response. There was only one way to explain that. The object had to be far more massive than anyone had calculated, so they ran the numbers backward, using the weak acceleration to estimate the actual mass. What came out was stunning. Over 33 billion tons of solid matter, with a nucleus roughly 5 kilometers across. If this discovery were random chance, it would border on impossible. Avi Loeb was quick to point out the statistical impossibility of this. We've only detected 3 interstellar objects total, and one of them is this absolute giant. Something doesn't fit. Either our models are completely wrong, or there's something special about 3I Atlas that we haven't figured out yet. Now, understanding what 33 billion tons actually tells us requires diving into the science behind the shock. If 3I Atlas really weighs 33 billion tons, It can't just be a loose collection of ice and dust. There has to be substantial rock, maybe even metal, making up a significant portion of its interior. That tells us something about where it formed and what kind of star system it came from. One possibility is that 3I Atlas is a fragment from a destroyed world. Imagine a planetary collision in another star system, two worlds smashing together with such force that chunks of their cores get blasted into space. We could be looking at the remnants of an exoplanet, now wandering the galaxy alone. Another theory suggests it formed in the outer reaches of another solar system, similar to how comets form in the Oort cloud around our sun. But if that's true, it would need to be ejected with incredible force to reach the speeds necessary for interstellar travel. Then there's the more speculative idea. Loeb has suggested, though cautiously, that we shouldn't completely rule out the possibility of technological origins. He points to the unexpected mass and some preliminary detections of unusual elemental compositions as potential hints. Most scientists remain skeptical. The presence of a coma strongly suggests this is a natural comet, but the fact that such ideas are even being discussed tells you how far outside normal parameters this object really is. The truth is, the more we learn about 3I Atlas, the harder it becomes to fit into any neat category. It's too massive for a typical comet, too active to be a dead asteroid, and too fast to have originated in our solar system. And if objects like this are more common than we think, that means one thing: we've been missing them. But the reason this matters goes far beyond just one strange comet. If massive interstellar objects are more common than we thought, that means our current search methods are missing the vast majority of them. We've been calibrating our telescopes based on assumptions that might be completely off. That directly connects to planetary defense. If a 33 billion ton object were heading toward Earth, we'd need years of warning. You can't nudge something that massive off course with current strategies. The sheer momentum involved changes everything. Then there's the scientific opportunity unfolding right now. ESA has positioned Mars Express and the ExoMars Trace Gas Orbiter to observe 3I Atlas when it passes near Mars this October. The James Webb Space Telescope will analyze its chemical composition, looking for signatures that might reveal which star system it came from. Understanding its origins might not just explain one comet. It could rewrite how we think planets are born. That's the premise behind astrophysicist Suzanne Faltzner's work, which explores how wandering interstellar objects might seed entirely new worlds. She has proposed that interstellar objects like 3I Atlas might actually seed the formation of planets in young solar systems. When a new star forms, it's surrounded by a disk of gas and dust that takes millions of years to clump into planets. But imagine an interstellar object falling into one of these young disks. Instead of starting from dust grains, you suddenly have a ready-made core that can immediately start pulling in surrounding material. It's like giving planet formation a head start. Faltzner's simulations support this idea. She found that massive stars are better at capturing interstellar objects, and gas giants are indeed more common around bigger stars. If this theory holds up, it means interstellar objects aren't just cosmic debris. They're active participants in galaxy-wide processes, seeding planetary systems across hundreds of light years. And when you step back and reflect on what this discovery means, what strikes you most is how a 33 billion ton object can remind us how little we actually know. We live in an era of incredible technological capability. We've photographed galaxies billions of light years away. We've detected gravitational waves from colliding black holes. We've landed rovers on Mars. And yet, a 33 billion ton object can cruise through our cosmic neighborhood and completely surprise us. Despite all our knowledge, space remains fundamentally mysterious. Most of what exists out there moves through darkness, carrying stories we'll never fully know. 3I Atlas will continue its journey, It'll swing past Mars this October, then skim behind the Sun at perihelion. In December, it'll pass Earth at a safe distance. Then in March 2026, it'll fly by Jupiter before curving back into interstellar space forever. But the data it leaves behind will keep scientists busy for years. Every observation is a clue. Every measurement is a window into processes happening across the entire galaxy. That's the nature of discovery. You never really finish, you just keep peeling back layers, revealing deeper mysteries underneath. The finding that 3I Atlas weighs over 33 billion tons isn't just a correction of earlier estimates. It's a fundamental challenge to our models of how interstellar objects behave. And here's the beautiful thing about science. It's about asking better questions. It's about being willing to say we were wrong when new data demands it. And it's about maintaining that sense of wonder. 3I Atlas is a reminder of that. A 33 billion ton reminder that there's still so much we don't know. Thanks for watching. What do you think about this discovery? Drop your thoughts in the comments below. If you enjoyed this, hit that subscribe button and share this with someone who loves space as much as you do. Stay curious, because the next revelation could be even more surprising than this one.